Okay, as I was saying, when I glanced at this at the first look, I immediately saw 0, -4, and I said 0 squared plus 3 times 0 minus 4 is -4, and it's 0, -4 is a y-intercept, and it works in the first equation. And it looks almost like it would work in the second one, but they switched the x's and the y's. I know that if I put 0 and -4 in this, I'm going to get 0 equals -4 minus 4, which is not true. I know that A is true for the first one, but not the second. I'm eliminating it, and now I'm going to try 2, 6. Now, the thing is, it is a lot easier to test this equation than this one, isn't it? So what I would do is I would test this first one for all the answers, and then I would come back to this one and test it. So I'm going to test this first equation, x equals y minus 4. So I'm going to try 2 equals 6 minus 4. Is this true? Yeah, looks like that could be an answer. Let's test the next one. Is 3 equal to 14 minus 4? Is this true? No. Absolutely not. That's out. Notice that I'm putting the x first and the y next because that's the order that they gave it to me in. 5 equals 9 minus 4. Is that true? Yeah, this one's okay, and this one's okay, that one's out. So it could be B or D, and all we have to do is test it in this one. Now, there's other ways to do this. I mean, you could do this a number of different ways, but I think this is the fastest and the most efficient. Now, this time you need to be careful. You need to put the y is the 6, and the x's go in both places. So I have 2 squared plus 3 times 2 minus 4. Let's see if this one works. I've got 6 equals 4 plus 6 minus 4. Uh-oh, looks like that's it. Looks like B might be the right answer, and I'm going to put 2 checks. Now, when I classify these, I put a single check if I think I'm probably right. If I'm almost sure I'm right, I put 2 checks, and I'm very sure on B. But I have not tested D. So maybe I made a mistake or something. So I would come back to it and maybe put a star on it if I check D. For now, I'm done, and I'd move on because you don't want to overspend time if you can help it. Try a different one. Try another one. Okay, guys, to be safe on number 11, I am going to draw the 2 triangles separately. And I think it's a lot safer and a lot better to do that because it doesn't take very long. And I'm going to draw a triangle ABC. Just like this, A, B, C, and I'm going to put the 28 degrees in triangle A, triangle ABC. Now I'm also, and the reason I use triangle ABC is because I've got AB over BC, and I've got 2 sides of this triangle. Now I also have this little triangle, BDC, and the thing is, the C matches up with both triangles. Does everybody see that this on triangle ABC is the same as this angle on triangle DBC? See that? And this angle is B, and this one is the D. And what this allows me to do is to write them next to each other so I can see what I'm looking at. Here's my 2 triangles that I drew. And I drew them so that angle C is right there. I had to kind of reorient this one a little bit. I had to flip it up so that the D was up here in the same position as the B. And this is from 28 degrees. If I look at this as my reference angle, this is the AB is the side right here on the top over BC, which is the side across. So it's top, across, and that means that I want this side over this side, BD over DC. If you don't redraw them, it's really hard to see that AB over BC goes with BD over DC. and it's A. BC over AC isn't even a possibility. AD over BD, not a possibility. And DC over BC. This is the one that would mess you up. If you look up here, it may look like it's the right one, but it's probably not. I'm going to put an A for this one because I think it's correct. Redrawing the triangles was a trick on that one. And again, I'm going to put 2 checks. I would test this one just to make absolutely sure that it's not correct. But I'm pretty sure about that one because it was this one over that one. So number 12 looks like you're supposed to simplify this thing. The trick here is that you have to realize that these exponents get distributed. So this is x squared y to the third, and this is a square root or taken to the 1/2 power. So I'm going to distribute these. We want to see what numbers go up here in the a over 3 and a over 2. Let's see what we got. I'm going to distribute my 1/2 to both of these parts. And in case you can't see it very well, I'm going to rewrite it. X squared y to the third raised to the 1/2 power. This literally means the square root, but you have to distribute exponents over multiplication. That's going to give me x squared over 2 and y cubed over 2. That's the first part. My second part is x squared y cubed to the 1/3 power, and I have to distribute this one. So I have x to the 2/3 and y to the 3/3. When you take exponents of exponents, you have to multiply them. This is just something you have to know. If they didn't have fractions, you would be able to see why it's true. With the fractions, you can't necessarily see it. Now, when I multiply these, be careful. I'm going to add the exponents. So x to the 2 halves and x to the 2 halves gives me x to the 4 halves, or x squared. Oh, no, it isn't. That's 2/3. Sorry, can't see. This is 2/3. This is x to the first. I'm going to go ahead and put these with a common denominator, and because I need to add the exponents, but all I have is a 1 here and a 2/3 here. So this is x to the 3/3, and 3/3. That's the same as 2 seconds. And when I add these together, I get 5 over 3. A little hard to see that. This one is a 1, and that's the same as 2 over 2. And it looks like that one is going to be 5 halves. And it sure looks like 5 is my A up there. Hard to see. It requires that you know that you have to distribute and multiply exponents here. You have to add these. You also have to get a common denominator. There's a lot of stuff going on these. But it's definitely 5, and I am almost certain. I'd say 99% on that one.